Okay. Well, good evening, everybody. I'll turn up the volume here so I can hear people join and make noise and stuff. Hey, it's session 7. Uh, oh, wait. Okay, sounds like a side conversation there. Hey, everybody, it is session 8. We're at the end of week 4 here, just about reaching the midpoint of the course, which is kind of hard to believe. Things are coming fast and furious now. So Project 1 was due tonight. Project 2 is coming up next week, and last time we learned about Project 3. So, for the next couple of weeks, there's going to be lots of stuff to manage, lots of stuff in progress. And I appreciate everybody who submitted their Project 1 already. As I hope you saw in the chat, if you submitted it early, I had a few minutes before class, like during office hours, and so I ran those submissions through the grading script and gave feedback to a handful of people where it's like, oh yeah, hey, this one didn't, this didn't work. Let's get stuff working. And so then do check your email for that. Also, while we're doing pair programming tonight, I'll look for any more submissions that come in and try to get you some feedback as soon as possible. You're not getting your grade yet. The graders will grade your assignments, assign you scores and things like that. But I wanted to just give anybody a heads up on something that was fundamentally wrong or just like a key a key test case that you missed. So tonight we're going to learn about continuous integration, and which is an important concept in software engineering and something that really helps you get fast feedback on what it is that you're doing as you're doing it. But we'll dedicate most of the class tonight to the second pair programming activity. And so then, thanks for joining. We got a handful of people here in the classroom, and then also we're doing remote pairing tonight. And so then we'll see how that goes. It'll be, I hope it's a good experience for everybody. First, I wanted to open the floor for Prime Minister's questions. What can I tell you? What would you like to know about Project 1? Anything about Project 2 on your mind, or just anything else you want to talk about? Yeah, there's technically only one resubmission, and anybody who got feedback tonight, it doesn't count as like a late. Well, it doesn't count as like a resubmission. So I think I noted that in the email I sent to people. So as long as you get it in by like Friday at 5, it'll be okay. But yeah, basically, yeah. Yep. Yeah, right. Hey, it's the first assignment. Let's give everybody a little bit of grace. It's hot out. Yeah, hey, do we need a reason? Sure. Yep. Right on. I'm a cool professor. I'm not a cool professor. Anything else about what's going on in the course? Well, how do people find Project One? Sort of like now that it's done, or maybe you're almost done. Any I don't know, any feedback, any observations that you want to share about like what your experience was like?
Test-driven development is
Oh,
just approaching it that way.
Yeah.
Through just it's completely different, I guess.
Test-driven development is very different. Yeah, yeah.
Yeah. I think the way I imagine it in their programming is that it kind of feels like the testing level. They're just like, I just want to get at the code.
Yes,
Yeah.
it's that discipline that you need to say, oh, I know I need to write, I want to write the code, and you will,
Yeah.
right? And it'll be shortly, you just gotta write that test first. And I know kind of how frustrating and how unsatisfying that can seem at times. But like what I've learned is that by just going in baby steps, you get there faster, you get there with better quality, and I've come to actually appreciate like driving things from red to green a lot more than just like, look, I wrote all this code and like, does it really work? I don't know. And then you spend a whole bunch of time about. For me, that just um, not only well, it's just less efficient and it's taking more time. But your mileage may vary, and I appreciate you all learning it. Right, you're here to learn, here to experiment. Hey, what you do in your other classes or what you do professionally, probably much more up to you. But I want to make sure that you have. I want to give you the opportunity to explore this. Right? It's a college, time to experiment. Ooh. Excellent. Hey, so Tin, I noticed that you asked a question here in chat a couple minutes ago. Does anyone do a Code Force? What is Code Force? I don't know. Is that like Space Force, but with code? Or using the Force, but with code? Excessive Force, but with code? I don't know. No problem. Okay. Any other questions before we dive into it? Or any other things you'd like to discuss before we dive into it? Let's dive into it then. So, tonight, if you watched the lecture on Maven, I hope you did. Um, it's all about the projects that we have and building them and having an automated build process, right? You've been using Maven since, I don't know, session 2 or something like that. But so far it's probably been magic to you, right? You run the command line, you know what it does, it builds your code, runs your tests, and all that stuff. But you didn't, we probably didn't know how it was done or really all the steps involved. And the goal of the Maven lecture is to give you some background there. Now, you're not going to be writing your own POM files in this course, but I think it's a really important concept to see and to know and be educated about a build system. Because really, software of any reasonable size, more than anything, it's not trivial, you're going to want to have a build system to manage your dependencies, to give you a repeatable process that is consistent across multiple developers for building your software. Right? It takes a lot of the complexity and toil out of building software. You just run a command and gets all of the third-party dependencies that you need. It builds all your code, make sure everything's configured correctly. You don't need to worry about that. We have robots to do this for you. And so building on top of that, what I want to talk about tonight is continuous integration. So when we develop, and certainly when we learn to develop, we work in our own development environments. And so these days, there are online or cloud-based development environments, but most of us are probably still using either our development machines or using like a PSU machine where we have our own sandbox, and this is where we do our work. Right? This is where we experiment before we then share our code with other people by committing it to a code repository like GitHub. And that's great for development and working in your own development. But when it comes to getting your code out to your users, how does that work? Now, I mean, here again, in your classes, well, actually, you have experiences in your classes because you have to submit your code for grading, right? So here we have the submit script. I don't know what you do in your other classes. Maybe you post a zip or something on Canvas, or hey, maybe there are some classes that use GitHub and say, oh yeah, right, I submit from this particular revision, and that's the thing that's graded. In production environments, there are a couple of models for getting your code, the code that you write, out to your users. Traditionally, for sort of on-premise software or software that runs on either an on-premise data center or a data center for a particular organization, or if you're writing like desktop software, it meant like someone will go to the store and pick a box, and then get the floppy disk and put it in. Right there's that model, which means that literally like your code would go into a manufacturing process whereby someone would put it on a disk and then ship it to Best Buy or whatever. These days, of course, it's posted to some website, you can download it, or there's an app store or something like that. Alternatively, if you're developing a web service or something that is cloud hosted, the code is built and then, deployed off to the cloud, right? You have some service that's running, and that service gets updated with your code. Then when it comes, so then when you think about, there are all of these steps involved to take it from the code that you write to the code that goes to the user. This is referred to as a build pipeline. And so then, it's like akin to a manufacturing, pipeline, or I think of an assembly line, like building a car, where there are all of these steps along the way that your code goes through to get there. Now, in those steps are these tools that build and assemble and deploy and test and validate your changes. And so, like here again, we learn about Maven. So Maven is a build system for Java programs, for Java components, and it's standard. It's it's optimized for sort of plain old Java applications, and as we learn about next week, web applications. And it's really good at it because what it provides is a known quantity for building software that everybody can have a similar experience with, and so then you get consistency. Once we had these build tools, people still had the problem of saying, well, great, everybody's building in their own environments, and that led to some problems because sometimes there'd be different tweaks in the environment. Oh, someone would have a different version of a library. Hey, building on Windows works a little differently from building on Linux, and sometimes the artifact back in the old days, the artifacts that were like developed on somebody's desktop, didn't always work consistently in production. So people realized they needed a sort of a clean room environment to build it, and hey, let's automate that process. When I started in the profession, there was a build engineer that a couple times a day would literally go get the latest source code and build it all themselves, and that would be the pristine build that or the clean room build that then people would test and eventually deploy or send out to users. Over the years, we realized that involved a person, which meant it was slow, it was expensive, it was error prone, and so it was a good candidate for automation. And so this concept of continuous integration emerged. And continuous integration basically provides feedback on your software on its way from the source code repository out to the user. So this solved a lot of problems. Got rid of this whole worry about hey, it works on my machine, but no, not the real environment. It also provided feedback on errors, like, hey, when the code doesn't compile or when someone introduced a change that caused automated test to fail, a unit test or integration test, people knew about it. And because everything was automated, it would do things like send out emails or it would literally turn red, have red flashing lights go off in the development, in the development bullpen and things like that. And also, it provided an opportunity to establish quality gates in the software. So, of course, it would test things like it does compile and does the test run. But then it also could have automated analysis of the software. Things like looking for, bad code patterns. It's like, oh, hey, you've got a little something smelly here. Oh, you didn't check for a null, things like that. It could do other kinds of source code analysis, looking for, third-party libraries that have known vulnerabilities in them. Those kinds of things. And what this did is, all these quality gates prevent changes from going into production that really shouldn't go into production. And it really led to this notion of a software supply chain, meaning that your code includes a lot of third-party code, and make sure that the third-party code that you're using has good pedigree, doesn't have known problems. And this is actually a serious issue. There was a vulnerability in a piece of cybersecurity software that was a malicious vulnerability added by bad actors, probably sponsored by a state, to that very subtly and over a series of months polluted the build pipeline, polluted the software supply chain. And it's basically the software equivalent of putting poison into the aspirin, into a pill, where it's like a bad guy got in, a bad person got in, and as a result, then software that was deployed on hundreds of thousands of devices all over the world, including in air traffic control rooms and airplanes and all sorts of things like that, was vulnerable to attack, and lots of people were impacted. And so it just further emphasized the importance of having, to be able to understand the quality and the pedigree of the things that you're putting in your software. Continuous integration is all about automating things so that it's not only faster and cheaper, but also less error prone. And automating the entire end-to-end process of, again, going from I have a change that I want to make to getting the change out to the people that use our software. This has some really nice benefits. Because there's so much of this is automated, it encourages developers to work in smaller batches, to commit their code more often, so you can see little changes get to the user. And as a result, capabilities were able to be delivered to users sooner, and that's a really good thing, right? The process that used to take months to get a change out to the user. Well, now between continuous integration and of course the ease of deploying to the cloud and getting software from the cloud, allows you to just limit the time between someone has a good idea and someone is able to take advantage of that idea and actually have the idea implemented in the code. So anyway, that's what continuous integration is all about. Has anyone encountered continuous integration before, either professionally or in their classes? Is this a topic that's discussed? Yeah, you've seen it before? Yep. Was it here in school or was it professionally? Yeah, Jenkins is a very popular continuous integration tool. It's basically the workers that go out and that perform these builds. Great. Yep. Anyway, that's what continuous integration is all about. So what does it look like in practice? Well, there's this, there's a tool like Jenkins, or as we'll see, GitHub has something very similar built in that does the following. It basically sits there and looks for changes in the source code. So it will pull the source code repository and say, hey, have there been any changes since the last time I ran a build? If there is, it goes off and performs a build. It builds in a clean environment. And actually, these days, so many aspects of the environment are clean. So it's not just like starting out with a clean checkout of your code base. It'll provision a new VM. So a lot of these systems now will say, great, provision a VM that has the ability to build, so it has the operating system and everything like that. It goes and it fetches the latest source code. Then it'll build the code, download any dependent libraries from a repository, from an artifact repository. It'll get all the tools that it needs to compile, to build, to run the tests, all that kind of stuff. After it builds the code, it will run the automated tests, both unit tests and integration tests. It'll run analyses on the code to identify, hey, is there some a problematic pattern? Is there a known defect in the code? Is there a third-party library that is problematic? It may also create documentation and the reports about the analysis so that people can consume and learn about the quality of the build. And then packages all of the build artifacts. So it'll say, hey, let's say you're building a jar file that has a Java library, or as we'll learn about next week, there's a web application that can be built from Java code, right? It packages the artifact, and basically then it goes off and delivers it to its final destination. So it'll like deploy an artifact off to an artifact repository, or it'll do something like I don't have it here, or it'll do something like deploy it all the way out to AWS or Microsoft Azure or something like that, where the software ultimately runs. And the beauty of this is that this all happens automatically by the continuous integration server, the continuous integration process, and that that you as a developer, while you may get notified if something breaks or whatever, but if you don't, you know that everything is now available for the users to consume. So those are the steps of continuous integration. Now, what does this mean for this class? So, how do we experience continuous integration? Actually, has anybody gotten an email from GitHub saying it's like, your code is broken? Yeah, some of you have. That was continuous integration. So what you get out of the box with the Getting Started repository is a repository that is configured via this Maven.yaml file, which tells GitHub to perform a continuous integration build under certain circumstances. So it basically says, hey, listen, when there are changes that are pushed to the main branch, go off and do the following. It'll provision a new machine that runs the latest version of Ubuntu Linux. It will then check out the latest code on on that machine from the main branch. And then it'll build a project, build your project using Maven W verify. And it actually has two variations of the continuous integration build. It does all of this first with Java 21 to make sure that your code works on Java 21, which is like the latest stable release of Java. And then again with the, well, actually, Java 21 is the long-term support, I'll say that. So it's super stable, and it'll be supported for a long time. And then again with Java 24, which is like the latest and greatest. And then, as many of you experience, hey, if there's some problem with the build process, yep, then the person who either owns the repository or has made the commit will receive an email. And, the email hopefully gives you some helpful tips on how to go learn more about the problem that was encountered so you can go off and fix it. So let's take a look at that YAML example. Let's see here. Let's take the one here in the JV coding repository. It's in a .github directory in workflows. So yeah, Maven has this, sorry, Maven, GitHub has these capabilities called actions and workflows. It's configured here with this file. So again, anything that gets pushed or a pull request that is to the main branch or anything that ends in dash snapshot will trigger a build. And actually, let's see here. I don't think I have any pull requests for this branch. But actually, I can go, I might have an example that I can show you from the koans repository. So GitHub and JV coding, and we'll say Kata, sorry, the Kata's repository. Kata's, and we want the summer one. I think I saw that someone put up a pull request the other day. Oh yeah, I've got some pull requests that are even open. These are like the katas for next time, but I've been making pull requests here, like when I added the Gilded Rose kata. So I just wanted to show you, a pull request is the following in GitHub. So as you may recall, Git has this branching mechanism, right, where you can say, hey, listen, there's like the main branch that everybody's on, but I can create branches off of that, and I can work on some code independently from what's happening on main. And then when I want to merge that code back into the main, I can create in GitHub what's called a pull request, which is basically a request, a thing that has a workflow. It says, listen, I've got a bunch of changes on this branch. I'd like to merge them into main. And it's an opportunity to collaborate and have people then weigh in on those changes and provide feedback before ultimately they decide whether or not that code should be merged. I don't have a good example of a collaborative pull request because I'm mainly working off with myself. But I created this pull request here when I wanted to add the code for the Gilded Rose kata. And okay, this is kind of a weak example. I didn't provide a description. I was kind of being lazy here. But but each one of these represents a commit that I made to the repository, and then I made to the branch, the Gilded Rose kata branch, and then pushed up to GitHub. And as I made my changes, you'll see at some point there's a little green check mark here. A green check mark represents a continuous integration build. And because it was green, GitHub is telling me, it's like, hey, listen, when you made this change, yep, everything passed. And here again, what did it do? The continuous integration build, actually I can probably click on it. I can see everything that was run here, and I can get the details. And this will tell me all the steps here of the continuous integration build, which are, well, essentially lined up, right, are specified right here in the YAML file. Again, it says, yeah, run a build on the latest version of Ubuntu, run it with both 21 and 24. And what do you do in each build? Well, I'm going to check out the code. I'm going to set up Java, and then I'm going to run Maven W, and just do the verify phase of Maven, which will do the end-to-end build, right? It'll compile the source code, it'll run the unit tests, it'll run the integration tests, and make sure everything passes. And so that configuration is executed here. We've got those same steps. And then the interesting one right here is the build the Maven project. And so this is where it runs the command. And then there's a whole bunch of output as it downloads a gazillion files. But hopefully, if I can scroll down here to the end, yep, it says here's a summary of everything that happens, and all of the tests in the all the submodules, all the projects within the cause repository all passed. And I didn't have to do anything here to get all of this feedback. If we then go, and that's the thing I love about continuous integration, right? The minions are off working in the background. The robots are, automation is doing all of this for me, and it's telling me what passes and what doesn't pass. Another good example of this is actually if we look at the main branch. If we look at the history here, we can look at the following. We can look at what we were doing. Well, not on Monday, but let's go back to last week, last Wednesday, which would be, is that the 9th? Yeah, sorry, yeah, the 9th. Last Wednesday was the 9th, and here's when you were all committing. And we get some red X's here because yeah, at some point, I don't really care who, right, someone checked in some code that didn't compile or that didn't have a passing test or something like that, and GitHub tells me about it. So like on Wednesday night after everybody got home, I went and looked at the state of the repository, and it was kind of a mess. So, okay, it's cool. And so what did I do? Well, then then I don't know, a couple days later, I went back and I just commented out some code and got everything compiling again. And then my continuous integration told me that things were green. And so great, now I can confidently work from main. And I did things like added the katas for tonight. And actually I added Gilded Rose, and we worked through that. And as we were, on Monday, as we were working through the Gilded Rose kata, every time I pushed up to GitHub, I pushed directly to main. It ran the continuous integration build just to make sure that everything works. And what this gives you is feedback on what you're doing. It tells you when you've broken something, and this is really important, right? We don't want to, have our stuff broken for very long. It's much easier to fix a bug shortly after you've introduced it because you're familiar with the changes that you just made, and so there's a smaller window of changes that could have broken. So, continuous integration, having things built, automatically. Hey, it used to be like really revolutionary. Now it's just how software is built, and it's so much better for it. It's an important part of contemporary software development because it helps you get feedback faster, helps you deliver things faster and more, more confident because it has higher quality. If you want to learn more about continuous integration, here are a couple of really good sources to just sort of get an idea of what CI is all about. It helped influence this document right here. And it's super easy to do in GitHub, and it's just great that GitHub gives you all of this all this power basically for free, and have it run everything for you. Is there anything else you'd like to know about continuous integration? Yeah. Okay, right. So you've got a really big code base. There's no CI. Where do you start? Well, I guess first of all, it's understanding your build pipeline and what is the most toilsome thing that you could automate, right? Automating something simple probably doesn't really help. So then I think the the first thing I would do is probably look at the build system. If there's not a well-defined build system, that makes it kind of tough. If there's like some homemade, homegrown script that builds everything. Okay, that might make it kind of difficult to integrate into something like Jenkins or or GitHub Actions. But if you've got a decent build system, then I'll plug into Jenkins, plug into GitHub. If it's open source, then use GitHub to get the feedback. If it's something that you're building in your own environment, stand up a Jenkins server, which is actually way easier than it used to be, and get going from that. And then also look at your end-to-end pipeline, and again figure out what you want to make easy. Sometimes it really is making the early part of the build, just compiling and running the tests and things like that. Making that easy can help a lot, and then you sort of take it. You have to manually pick up the artifact and put it into production. Or you might find that is the other part of the build pipeline, which is worth automating. So, for instance, if you've got either some complex or error-prone steps at the end, the more things that you can automate, the more toil it'll reduce and the less error-prone it will be. I know that at work there are some sort of kind of like the last mile problem where it's like we've got this like gorgeous build pipeline for building all these artifacts. It's our documentation. That sort of like builds all the way up to here, and then in order to get it out to the website, it's kind of this awkward process that's coming out, and we don't like it. So it's like that's a place where I would look to say, well, where can we optimize that? What are the things that we can make better? And actually, another side note on that. There's a technique that I heard people talking about, which I really like, and I've tried to use it a couple of times, and haven't found exactly the right use case, but it's the following. So let's say you've got some process right now that is super manual. First thing you want to do is write down, like in a document, in Markdown or whatever, write down here are all the steps to do it, because you want to understand what it really takes to perform it, right? And make sure you've captured all the things. And like say, great, copy this file from here to here, and then run this command on that, right? Just write it all down. And then take that and turn it into a script. Now, the first thing the script does is literally like print out every step. And then it's like, do this and hit return to go on to the next step. That's actually a really good, a good piece of automation right there. Because even though it's not really, the computers aren't doing very much, it's getting you used to running a script to do it. And then, once you have all those steps, figure out which ones can be automated easily, right? Maybe copying it from one location to another. Yeah, right. Okay, turn this into, use a SCP command here, an SFTP command or whatever, to do that. Oh, great. And what you do is just, work in small steps to automate the stuff that first is easy, and then the stuff that is really toilsome. And then even if you end up with some sort of, mixture of like, perform this step manually, go email this person or go like pick up the phone and talk to someone, do whatever you have to do. But then after that, okay, great, then, automate the next 3 steps. It saves you a lot. So it's not exactly continuous integration, but for me, it's a really powerful way to go from an unknown manual process to a known, gradually more and more automated process. Nice. I'd like to take a little bit of time to talk about some cool stuff in Maven. So let's see here. I don't want the Kata's project. Instead, I want to work with the Joy of Summer 2025 repository. So since we're talking about neat build things, I want to talk about Maven's capabilities for doing analysis on a project and creating reports about it. So, you've seen Maven's ability to create built artifacts, like jar files, right, and all the the pieces, parts of the build to compile the source code and run the test, all that good stuff. But there's kind of some downstream stuff from that, which I want to take a little bit of time to talk about and explore. And it's Maven has the ability to build a website for any project. So here I am in my checkout, and I'm going to do the following. Let's see here. I'm going to run the Maven W. So there's this is documented here on the page. I'll get back to the GH pages in a little bit. Or maybe it won't. Well, so between Maven and there's this feature of GitHub called GitHub Pages, and maybe you've seen this. You've seen people that have like a GitHub.io website or something like that. And the way this is accomplished is this little trick that you have in GitHub. If you have a branch in your repository called a gh-pages, it will, and you check into that branch, it'll actually host the content on that branch up on your website. So I'm going to follow these steps right now to create one of these GitHub pages, and then we will see how to build a website for your project from Maven. So let's see here. First, I'm going to create the branch. Do that here. I'm going to check out that branch. I'm not going to remove the README just yet. I'm going to push up the branch to GitHub. And then what this gives us is the following. So if I go to a URL, which is my my GitHub user in all lowercase .github.io/joyofcoding summer 2025, I'll get excuse me, I will get basically a website that's hosted from that GH Pages branch. So let's see here, HTTPS David Whitlock, which is my GitHub ID, just like this. So that's a 404. But now if I say Joy of Coding Summer 2025, it prints. What it serves by default is the readme.md rendered as HTML. That's neat, but that's not what I want. I want to have like this website that's generated by Maven. So for the time being, I'm going to delete. I'm going to go back to the instructions here. I'm going to delete the README. And the reason I'm deleting this is because I'm going to create an index.html file, but for some reason readme.md takes precedence over that. I don't know why. I'm going to remove this, and then I'm going to commit, and then I'm going to push up there. And so now it's on my GH Pages branch. Oops. So I reload this, I'm going to get a 4. Oh, that's interesting. Once more with feeling. Oh, it shouldn't be there anymore. I wonder what happened there. So I pushed up GitHub Pages. Let me just go look in the repository right here. Maybe it didn't. Oh, did I not do it? No, I did it. Git RM. Yeah, there's no README anymore. Maybe it just hasn't synced or something like that. There we go. Now it's getting a 4.4 like I expect. So because there's not a readme.html here, it's not. There's nothing to serve up. Actually, I don't know. For the sake of argument, can I write? Let's see here. Oops. I'm just going to quick put together a very easy HTML document title hello. Great. Here is a very simple index.html file. Oops, come on. That's weird. Okay. Now I'm going to add the index.html. I'm going to commit. I'm going to say added simple index.html. I'll push it up. So I'm going to reload it here and just make sure it's there on the branch. Yep, there's the index.html. If I look at it, it's like super old school and hokey. If I reload, it takes a little while to sync apparently. It should load that page here in a minute. Oh, and look what happened when I pushed a change up to this branch. It started the continuous integration run, and that's what that little I want to say mustard colored dot means is that this revision has is pending a continuous integration run. Oh, that's interesting. Oh, I see. So this is the thing that actually deploys it. Cool. That's neat. So I guess now that all that is passed, then I should see. Yep, there it is. There's my index.html. Okay. So what I just demonstrated is that when you're working on this GH Pages GitHub branch, when you commit HTML or you commit content to this branch, it is served up at a URL like this. It's your username for GitHub, github.io, so not com, io, and then slash the name of your repository. Okay, so that's how GitHub pages work, and that's neat. Now let's talk. Let's go back to the main branch. Now let's talk about how Maven websites work, how Maven sites work. Okay, so now I want to check out the main branch again here on my local machine. Now I'm on main branch. Okay. Now let's see here. In the we're going to look at the pom.xml. Now the pom.xml is the configuration file for Maven, we've looked at these a couple of times before, but now we're just going to learn a little bit more about them. Okay, so we should change your user ID. Let's see here. Where does this appear? Oh yeah, here the group ID. Oh, interesting. Yeah, I should change this to Whitlock. And then where else does it appear? Just there. And then also I want to replace my GitHub user ID. Here it is in lowercase. So do Whitlock. And there it is again. Whitlock. Does it appear anyplace else? Oh, there it is. I'm just going to do replace. Get user ID, replace all. Nice. And let me just show you, what I did. So the pom.xml has all sorts of information. It basically describes your project and then what Maven does with it. So it has some identifying information about the artifact that's created. It has the group ID, which every artifact in Maven land has three things: the group name, the artifact ID, and the version. So the group ID is basically me. That identifies you. It's like a Java package name, right? The artifact ID. This is the top level of the repository. So the artifact ID is just going to be calling it a joy of coding. If you look at some of the POMs for your projects, like the appointment book, you'll see that it has the same group, but its artifact ID is apps book, and it's like the name of your jar file, right? It's the name of your artifact, and then the version is 1.0.0. And it has other information like the name of the project, a description of the project, and then all sorts of additional information like the developers, right? And so like in the katas, you may recall that you fill in this information about yourself. It also has the dependencies that it have. These are the libraries that it depends on. So like for instance, it gets the projects dependency, the projects jar file for the class for a particular version. And this is how you get like the abstract appointment book, right? It resides in this file. And we get it for both the source code and for the tests. And then there's a whole bunch of configuration related to what are called Maven plugins. These are all the kinds of things that do work on your behalf. Here's one that you might have encountered before. There's the Maven jar plugin. This is the thing that builds the jar file. And you configure, here in the project, it configures the jar file plugin to have a main class in the manifest. And this is what builds the executable jar. And these are all details and one of the things you don't need to worry about, but I hope what you take away from this is that there is a configuration file called pom.xml, and it's the thing that instructs Maven what to do. So, et cetera, et cetera. It instructs Maven what to do, and it also describes your project. And so it has all sorts of information in here, like, hey, here's the organization that created it, and here's how to get more information about the project. It's like, hey, here's where my issues reside. So if I'm a developer and I want to contribute to the course, I want to contribute to the repository, here's where I would go for that. It talks about the license that's being used, and of course the developers. So this is all interesting information, and information that can be leveraged to generate, a website for your project. Now remember, Maven was developed for open source projects, and so then not surprisingly, you want your open source project to have a nice website that tells people how to use your use your code, use your library, whatever it is that you're building. Oops. Um, and so then there's a standard way in Maven to generate these websites. And so you do that with the following. You run the site phase of Maven. There's the same way there's a compile phase and there's a test phase. You can run the site phase. And so then this will run the Maven site. Now in the Maven site, it goes through and generates a whole bunch of reports about your project. And like I have our projects to be our Maven projects to be configured to do things like the following: generate API documentation, Java docs for the code, generate reports about the tests. I think a number of you have used the Jacoco code coverage reports. Remember how those are in a directory called site in the target? That's one of the things that's included in the site. Additionally, it has the reports will have all sorts of information about the project itself, mainly derived from the information in the pom.xml. So nicely format, hey, here's who the developer is, here's how to go find the project on GitHub, stuff like that. And then finally, there are all these other analyses that you can do. So for instance, I have something called Spot Bugs, which has this really cool database of like just bad code patterns, smelly things in your Java code that it will warn you about. And the thing I really like about this is that Maven makes this super easy. Yeah, once you figure out how to do it, but it's all standard. Everything is all taken care of for you, which really lowers the barrier of entry and makes it easier to just get started and then keep going with all these analyses. Now it's doing a lot right now, and that's why it's taking some time. But it's here it is. We're seeing it go by, generating various reports, doing various analyses. This is Java doc complaining that I've got some methods that don't have comments on them, which is all fine for now. But it's going through each one of the reports to generate the site. Why did I learn Maven? Because I probably learned Maven mostly for teaching the course. At work, we use something called Gradle, which is the successor to Maven. We'll see it when we learn about Android. We don't dive into it. I don't know. I have a weird mental block with Gradle. For me, actually, while this is doing its thing. So you run this site stage, and what this does is it basically it gets ready to deploy your site off to production, but it basically moves the files to a place that allows you to look at them locally. The thing about Gradle that Gradle's too hard, I gotta admit. Gradle is so much more flexible than Maven. Well, that's great, but I don't want to think that hard about my build process. I want the build process to be super easy, as simple as possible. So that's why I like Maven. Lots of other people don't like Gradle because of the flexibility. Oh, great, I can do whatever I want. Okay, cool. I don't want to think that hard. I want my Java projects to be easy. Anyway, so I ran this stage : site goal, and now when I open, let's see here, target site index.html, we'll see how it looks. Great. Here is the website. I'm going to make it a little bigger so everybody can see it. So here's a landing page for my website. And you can learn all sorts of things about this. And this is all generated from the code itself and from those pom.xml files. So I can look at things like, here are the dependencies that I use here in this project. And it tells you all about them. So like here are all my test dependencies. So like here's Hamcrest. It says, oh yeah, here's the version that you're using. Here's the license of it. Here's JUnit. The one I'm using there, and it links off to the website for those projects, and it gets all that stuff in the pom.xml file for those projects. And then it tells you all the transitive dependencies. So these are dependencies of dependencies. So for instance, okay, this like JSpecify, wherever the hell that is brought in from one of your dependencies. And remember how I was saying before, talking about the build pipeline and the software supply chain, this information is very valuable because you want to make sure that you are using known to be good versions of your software. Not you're using something like super old or something that's vulnerable. And actually, I don't think I have. I could go find out. I should probably go add a Maven report here that talks about that identifies vulnerable libraries. And so from this, you can find out things like issue management. So remember, here in my pom.xml, I had an issues section. Yeah, it's issue management. It says, oh yeah, it's managed by GitHub, and here's the URL. Well, when the Maven site is being built, it looks at that information here in the XML and generates some pretty HTML for it. It's like, oh yeah, here's a link off to where you can submit issues for the project. And so all this stuff is built out of the box. It just comes out of the box. Same thing with like, here's the information about your source code. Right, here's how, and this is like if you've got a, I wonder why I keep resetting. If you've got an open source project, you want people to know, here's how you go and get the source code. Here's how you go, access it. And all this stuff is generated for you by default. So this stuff is really cool. And there's also project reports. And so like, for instance, here is the API documentation that's generated. Looks like it's just generating it for the no, it's the koans and the stuff in my package. So like here, here's the Java doc that's generated for student, right? And we saw this the other day. And it links off to the API documentation for from the Oracle website, which is cool, the official documentation, so you can easily use it there. And if I had things working, I could get I could have it link off to the Java docs for my code also. Oops. Sorry, let me go back to the Maven reports right here. There are other reports. There's let's see here. Oh, if we maybe go into one of the projects, let's look at our appointment book project. Oh, that's not working correctly. I wonder why. You can also get reports. Are any of these working correctly? No, those aren't working correctly. I might need to fix up some stuff in my palms to get that to work correctly. We'll see. But we can also get things like, we were talking about those dependencies before. Here's a report that tells you if there are newer versions of your dependencies available. So here, for example, I'm using the latest Google Guava and latest Hamcrest, but there's a new version of JUnit, JUnit Jupyter available. Excuse me. It's telling me, oh, look, there's a new upgrade. I mean, that's something I want to do, right? There might be some bugs fixed, might be some vulnerabilities patched. Same thing with Mockito. It's like, oh, that's cool. This is all good to know. And then it gives you some more information down here. So all cool, super cool stuff. Now I'm wondering why those links to the child projects aren't working. And I'm going to take a look at something real quick. So let's see here. I'm going to go back to the appointment book. Here's what the problem is. This is a common problem, and actually I'm pretty sure this is described here in the README. And I think a couple of you might have come across this. Oh yeah, it even says so. So it's like, I should have read my own documentation here. One of the things in order to get everything to generate the site correctly is that you need to have the correct parent and child relationship between the projects. And by parent and child, I mean module and submodule. So if we go back to the parent, every Maven project has a parent project. And so the top level project here, its parent is like my, my top level, Joy POM, my Joy project, which defines like the version of JUnit that you're using and a whole bunch of dependencies. Actually, we can navigate to it here. And it's got a whole bunch of things. This all comes from code that I write, and it defines a whole bunch of versions of things and some plugin configuration. Probably not all that interesting. And out of the box, when you create a project, that is the parent. And the problem is that in reality, like my appointment book, my parent isn't the Joy project. It is the it's the parent here for Maven. So what I need to do, for the repository, code repository. So what I need to do is I need to make this joy of coding the parent. And so I'm just going to go and replace that. And that's what this this is saying right here. So for the child projects, I'm just going to go patch this up by replacing this. It's not telling me this is redundant, which is nice. Okay, I'll delete that. I need to go do that for all of the children, so I need to do it for koans also. And I'm going to change that here. Get rid of that. I'm going to do it for student. And then get rid of that. And now I'm going to run my, let's see here, I'm going to run the site again, and I think that should get the links working in the generated HTML. So bottom line here is that Maven has some really cool capabilities for building projects. This isn't something you need to do for the course necessarily. But if you ever find yourself developing an open source Java project, it's something you might want to leverage. Or if you've got some documentation requirement for your project, say it's your capstone, or if you're maybe in your software engineering class or some other class where you start building a project, it's super easy to do this. Kind of once you get everything configured. And by the way, if you do more Java work, feel free to leverage anything that in my Getting Started repository if you want to use that for other classes. Hopefully this is helpful for you outside of the course also. So it'll take a few minutes. Kind of a few minutes I don't want to take, but anyway, we'll just let it go. While it's running, is there anything I can tell you? Well, the next thing I was going to do is have everybody take a break. So let me just take a break now. Do this working, and then I'll quickly show you what it's like to. Well, actually, I'll just go and upload it to the website when the show will be done, because I do want to make sure we have enough time to do the pairing. So let's take 10 minutes now. We'll be back at 7 minutes past the hour, and then we'll dive into the pairing. Cool. So at the first part of class, we were talking all about continuous integration and Maven and things like that. And just to finish off, I staged the site, and then I ran this publish SCM, which actually takes the HTML that's generated locally and publishes it by committing it to the GH pages branch of GitHub. And now when I go to my site, my github.io site with the name of the repository, now I have the generated site from my Maven project. And this is what we were browsing locally over here. Now this is actually hosted up on github.io. And I can get all sorts of information, dive down into the details of my appointment book project. And I can look at the reports. Like here's the Jacoco code coverage reports, right? So this is included there. And as I think some of you had seen, we can drill down and see for each class what kind of code coverage you have. So this is neat, something that you maybe want to publish for this project. Oh, there's also things like spot bugs. This is a cool report that identifies what it calls bugs in the code. And like it's saying here in my project 1 class, in my main method, I'll make it a little bit bigger. There we go. It's complaining about something called a dead local store here on line 16. And if I click on this line 16, it brings me to a report about that, that has the source code all rendered here in HTML. And I think what it's complaining about is the fact that that I create an appointment object and I never do anything with it. And this is what a dead store is, but I can find out exactly what a dead store is by clicking on this link right here. It brings me off to the Spotbugs website. And yep, it talks all about that it is let's see here. Where is it? DLS dead local store. DLS, yeah, dead local store. Dead local store. Oh, there it is. Yeah, dead store to local variable. I guess it didn't load the page exactly correctly. But, oh, interesting. Price needs to be updated. But it says, and I'll make it a little bit bigger. You know, it tells you like why is it bad? The instruction assigns a value to a local variable, but the value is never read, is not read or used in the subsequent instruction. Obviously indicates an error because the value computed is never used. Right? It's just a nice little warning. And so then, hey, if you're ever curious about little issues that might turn into big issues, this report will tell you. So anyway, bottom line here is that all this stuff is possible with Maven. I just wanted to show you like what was possible. Not something that's required for the course, but it's something that I think for me really reinforces the power of a standard tool like Maven because it enables this whole build ecosystem. And so like someone wrote the spot bugs tool and they're like, wait a second, if I have a Maven plugin for it, then anyone that uses Maven could also use my static code analysis tool, which is a nice thing. All right. So that's a whole bunch of stuff about continuous integration of Maven. Let's talk about tonight's kata and get into some pair programming. So tonight, our kata is the diamond kata, and it's here. I looked on the website. I will also put it in the. I'll put it in Slack, and I'll put it. Here in the chat. Tonight's kata, and I'll put it in Slack. Edit this here. Should have done this earlier. Edit. It's kata diamond. Nice. Okay. So this is basically this is a super simple little kata. You give it an input of a letter, like capital C, and it prints a diamond, where the upper and lower corner, vertex, whatever, of the diamond is A, and then it goes to the letter that you, and then in the middle you have the letter that you entered, and then it goes back down to A. And so then what I'd like you to do tonight is go to the katas repository. And so then everybody who's playing at home, now it's time to go to the katas, pull down the latest changes from GitHub, either on the command line or by using the update project command in Git. And what you should see is that there's a new directory called Diamond that has a whole bunch of subprojects, one for each pair tonight. And this is where you do your code. It's very much like the other kata that we did, the leap year's kata. There is a Diamond main class. There are integration and unit tests for Diamond. Everything is empty right now. And your job for the rest of the class tonight is to go through and do pair programming. We're going to do, what did we say we were going to do? We were 10-minute rounds tonight. So each pair. So please, we'll do Pomodoros for each partner in each role, and then we'll switch roles after that after a 2-minute 2-minute reflection, and we'll have at it. So any questions before we get started? Yeah. Oh yeah, sure, yeah. I'll show that again. I went back pretty quick. You use the Git menu, and then you say update project. You can also say pull if you're on the main. I like update project because it fetches branches and stuff too, and it's a keyboard shortcut. So it's open Apple T for me. Okay, so I'm going to pause the recording. We'll go into breakout rooms. We'll also choose. We'll figure out which pair is here in